put in tan of 40 degrees and you hit equals, the calculator is going to tell you this decimal 0.83, on and on and on. And when we round that to the hundreds, it's 0.84. So tan of 40 degrees rounded is 0.84. Okay? That means the opposite side over the adjacent side of any triangle with a tan of 40 degrees is going to give you 0.84 as your ratio, opposite over adjacent. When you divide that fraction, it's going to give you this decimal. So since tan of 40 degrees also equals x over 50, since tan of 40 degrees equals x over 50, what we're trying to figure out is the numerator in x over 50 that would make this fraction, x over 50, be equal to this decimal, 0.84. Because 0.84 is the same thing as tan of 40 degrees. So x over 50 is the same thing as 0.84. Now we can solve this equation by multiplying both sides by 50. And when we do that, we get a rounded answer, right? No, exactly. When we multiply 0.84, which is a rounded number, times 50, we get x equals 42. So what this tells us is that if we have the fraction 42 over 50, that equals 0.84. And we know that this is the tangent of 40 degrees. Now, this is not how we're actually going to be solving these problems. I just want you to understand what it means when you see something like tan of 40 degrees or cosine of 30 degrees. All of that means is a decimal. You can think tan of 40 degrees. When you see that, think this decimal, which is equal to a fraction. That's all it is. So let's get back to our equation that we've set up here. We've set up that tan of 40 degrees equals x over 50. And we got x over 50 by doing opposite over adjacent. Now, we're going to use the same process algebraically to solve for x. We want to get rid of the 50 that's being divided into the x, so we're going to multiply by 50. Or another way to think about it is multiplying by the reciprocal. We're going to multiply both sides by 50 in order to get 50 out of the denominator and to get the x by itself. So what we end up with here is 50 times tan of 40. And we know that 50 times tan of 40 is approximately 50 times 8.4. We've already proven that, right? 50 times tan of 40 is approximately 50 times 8.4. We've proved that down here. But tan of 40 does not equal exactly 0.84. That's a rounded number. So we want to be more exact. So that's why we're going to put tan of 40 in our calculator instead of 0.84. So what we're actually going to enter into our calculator is 50 times tan of 40 degrees. So let's type this in. You type in 50 times, and then put second, trig, arrow over to tan, hit enter, type in 40, close your parentheses, hit enter again, and this is what x equals. Whoa. We're going to round this to the nearest hundredth, or excuse me, so the nearest tenth, and you actually do get 42 here. We get the same answer. You won't always get the exact same answer if you did the decimal version versus doing it with the trig, because we rounded down here when we did 0.84 times 50. Okay, but in this case, it did come out the same once we rounded our final answer in both. So the steps that you would show here are the steps that we just wrote, and what you put in the calculator is this step right here, 50 times tan of 40, and that tells you the numerator of your fraction, which is also the height of the tree. On this problem is just like the last one. Notice there's no information about the hypotenuse. We are looking for how tall our flagpole is. And the flagpole is some distance, let's say again, this is the person looking up at the flagpole. All right, so this is going to be tan of 35 degrees. It could have been a cosine or a sine if we were looking at different sides, like the hypotenuse. But it's not, because we're working with opposite over adjacent. Since the x is in the numerator, it's the same process as what we solve with 4. We're just going to multiply both sides by 24 in order to solve for x. That gets the 24 out of the denominator and the x by itself. What we actually put into the calculator is 24 tan of 35 degrees. And in the calculator, you don't actually have to put a times between your 24 and your tangent, and it will still work. When you plug into your calculator 24 times tan of 35, you get 16.8 meters, which is the height of the pole. Now let's look at an example where the x is going to be in a different position. Here we have a destroyer, which is our ship. Our ship is going to be up here, and it's going to be destroying submarines, and our submarine is down here. So here's our submarine, here's our destroyer. We're looking for the distance between them, which is our hypotenuse. We know that the angle that the destroyer is looking, or that the angle that the destroyer is looking down at the submarine is 31 degrees. The ocean is at the top, and the submarine is 200 meters directly below the ocean. So that's where our right angle comes from. So you can tell me what trig function we're going to be using here, sine, cosine, or tangent. We're going to find the sine of 31 degrees because we're working with opposite over hypotenuse. 200 is across from 31 degrees, and x is our hypotenuse. So that's sine. So here we want to get the x by itself, and this is a little trick here. You have to go through 2 steps to get it by itself algebraically. So what we're going to do is we're going to multiply both sides by x, and that will get x out of the denominator, because x times x in the denominator equals 1, or x divided by x equals 1. So we end up with x times sine of 31 degrees equals 200. X is still not by itself, so what we're going to do is we're going to divide both sides by sine of 31. This is just like having a decimal times x. If we had something, for example, if I had 0.5x equals 10, to solve for that, I would divide both sides by 0.5 in order to figure out what 10 equals. Same process. We're just trying to get x by itself. And we know sine of 31 is a decimal. Okay, when we do this, the sine of 31 divided by the sine of 31, decimal divided by itself equals 1, so the x is by itself. What we're actually going to put into the calculator is a division problem. We're going to put in the calculator 200 divided by sine of 31 degrees. So let's do that together. In your calculator, type in 200 divided by, and then do your second, and hit your trig button. And sine is your very first function, so hit enter, and then type in 31, close your parentheses, and hit enter again. Okay, so when we put that in our calculator, we get 388.3 meters, which is going to be the distance between the destroyer and the submarine. All right, so in this problem, we're looking for the degrees. This is the easiest one of all. I love this one. When you're looking for the degrees, in this case, we've got sine opposite over adjacent. So sine of x degrees equals opposite, which is 20, over adjacent, which is 100. This is a pure calculator problem. All you do on your calculator is do sine -1, and then put 20 over 100, the fraction, in. This is called an inverse function. You're doing the inverse of finding your fraction. You're finding your degree instead. So you just put this in your calculator, and that's your answer. So let's all do this together. So press sine, and then trig, go over to sine -1. It's your second one there. Hit enter, put in 20 /100, close that parenthesis, hit enter. Let's round this to the nearest whole. We usually round the degrees to the nearest whole, and we get 12 degrees when we round that. So now we know how to solve for the degree, and that's where you use your inverse function. We know how to solve for x in the denominator, and that's where you divide your numerator by your trig function, and we know how to solve for x when it's in the numerator, and that's when you multiply your trig function times your denominator.